Why does Instagram load instantly in Egypt and also instantly in Japan? The data is not coming from one server. It's coming from an optimized caching and edge delivery system. Let's talk about caching, CDN, and edge strategies. Why caching is mandatory at scale? Without caching, mobile app backend database response for millions of users, this becomes slow, expensive, unreliable, database overloaded, and caching reduces latency, server load, network cost, failure impact. Caching is not optimization, it's survival. Levels of caching in mobile systems. Caching exists as at multiple layers. Client-side cache, on-device, memory cache, disk cache, local database, HTTP cache, and it is used for feed data, images, API responses, offline first behavior. The strategy: cache, show immediately, then refresh in background. This is perceived performance. Application server cache. Backend layer uses in-memory cache, distributed cache, and the purpose: avoid hitting database repeatedly. For example, if a user profile fetched 1 million times per hour, cache it. CDN stands for Content Delivery Network. CDN distributes static assets globally. Instead of user in Egypt US server, it becomes user closest edge node. CDN handle images, videos, JS bundles, static JSON, app updates. This reduces latency dramatically. Edge computing strategy. Edge is more advanced than CDN. CDN caches content, while Edge can execute logic. For example, instead of backend validating every request, Edge server can validate token, redirect traffic, apply rate limits, personalize response. Edge reduces backend dependency. Architecture becomes mobile, edge node, origin server only if needed. Cache patterns you must understand. Cache aside, lazy loading. App requests data. Check cache. If missing, fetch from database and store in cache. Most common pattern: write through cache. Write to database, write to cache immediately. Ensures consistency. Write back, write behind. Write to cache, database will update it asynchronously. Higher performance, more risk. Stale while revalidate. Return cached data immediately. Fetch fresh data in background and update cache. Perfect for feeds. Cache invalidation. How hard things in computer science. Cache invalidation. Naming things. When data changes. How do you invalidate cache? Strategies: TTL, time to live, versioning, event-driven invalidation, manual purge, E-tag validation. Bad invalidation equal stale data bugs. Architect must design invalidation clearly. CDN strategy for mobile apps. Mobile apps depend heavily on image delivery, video streaming, app updates, static configurations. The best practices: compress images, use adaptive image sizes, enable HTTP/2 or /3, use cache control headers, use signed URLs for secure content. CDN should support regional failover, DDoS protection, SSL termination. Edge failover and reliability. At scale, system fail. Edge strategy must support multi-region backend, automatic failover, health checks, circuit breakers. If one region goes down, traffic reroutes automatically. Mobile user shouldn't notice. Reliability is invisible architecture. Mobile specific caching consideration. Mobile adds complexity, intermittent network, limited storage, memory pressure, background restrictions. Architect must define cache size limits, eviction strategy, offline expiration policy, retry strategy. Never let cache grow uncontrolled. Let's take a fintech example. In banking apps, you cannot cache account balance permanently, sensitive transaction history blindly. The strategy cache for performance, validate on critical actions. For example, show cached balance but verify before transaction confirmation. Security always overrides performance. Scaling globally. At global scale, users in Egypt, Europe, Asia, United States, strategy, multi-region backend, geo-distributed SDN, edge token validation, regional data, residency compliance, latency target under 100 to 200 globally. Architecture must be geographically aware. The architect mindset when designing caching strategy, ask yourself, what if cache becomes inconsistent? What if edge node goes down? What if stale data affects financial decision? What if CDN serves outdated configuration? What is the TTL and why? What data must never be cached? Caching increases speed but increases complexity. Caching, CDN, and edge strategies require multi-layer caching design, clear invalidation strategy, CDN optimization, edge failover planning, security validation, mobile-aware eviction logic. Thanks for watching and see you next video.